Dear students, how are you? Welcome back to another video of our Nishtimany course. Well, in section 6.4, the title is Inscribed Angle. Well, what kind of angles are inscribed angle? Regarding the definition, it says that an inscribed angle is an angle whose vertex is on the circle and its sides are chords of the circle. Remember that we call these kind of lines from a point to another point of the circle chord. We call them chord. So it says an inscribed angle is an angle which its vertex is on the circle, as you can see it is on the circle, and the side of the inscribed angle are chords of the angle, or chords of the circle. And always the measure of inscribed angle is equal to the arc across from it divided by 2. Or in another word, half of the arc across from it. For example, if the arc is equal to 90, so the inscribed angle is half of that arc, which is going to be 45. Well, inscribed angle is a kind of angle that its vertex is on the circle and the sides of it are chords of the circle. And the measure of inscribed angle always is half of the arc across from it. Here we have got two examples. First of all, in example 1 and example 2, well, we have different story in each of them. In the first one, so in both of them we are dealing with inscribed angle. In the first one, it gave us the inscribed angle and it asked for the arc, which is arc BC, against the inscribed angle. But as you can see, the inscribed angle's measure is equal to 78. So it means it is half of the arc. That's why we need to multiply it by 2 in order to get the answer. So 78 multiplied by 2, it is equal to 2 multiplied by 8, 60, 1 and 60. 2 multiplied by 7, 40, plus 1, 50. 156 degrees. It means the measure of BC is equal to 156 degrees. That's why half of it is equal to the inscribed angle measure, which is 78. Well, here in the next example, which is the second one, again we have an inscribed angle. Why? Because the vertex is on the circle and the sides are chords of the circle. Okay, so the measure of angle C, it is half of the arc. What is the measure of arc MN? The arc MN is equal to 60. So we need to divide it by 2 because we said the measure of inscribed angle always is equal to half of the arc across from it, which is equal to 30 degrees. That is all about inscribed angle. We have one more matter that we need to discuss about it regarding inscribed angle, which we call it congruent inscribed angles. Alright, so if inscribed angles, which means we have more than one inscribed angle. So if inscribed angles are made by the same arc, then they are going to be congruent. Look at that shape, guys. Well, the angle XAY, which means that angle is an inscribed angle. Why? Because the vertex is on the circle and the sides are chords of the circle. Look at the next one, the angle B, XBY. Again, B is an inscribed angle. And both of them across from the same arc, which is arc XY. Since their arcs are the same, so the angles are going to be congruent, which means they are going to be the same in terms of values. Alright, so if two inscribed angles or more across or made by the same arc, then we can claim that the measure of them are equal to each other because they go through the same arc. Here we have got a very interesting example. Well, as you can see, angle AC, AD It is an inscribed angle. Why? Because the angle is on the circle and the sides are chords of the circle. And then the measure of the inscribed angle is half of the arc against it. As you can see, the measure of this angle is 14. So it is half of the arc, which means we need to multiply it by 2 to get the arc. So 14 multiplied by 2, 28. And as you can see, guys, the angle CBD across from the same arc. So the angle B is going to be also 14, because both of them across from the same arc. So they both are going to be equal to each other. And the question asks, what is the measure of arc CD? So we got it, and it's equal to 28 degrees. And what about the measure of B? It is the same with the measure of A, because they have the same arc. So it is equal to 40 degrees. Next. Here we have got a special case of inscribed angle. What kind of special case it is? When the chord, okay, make a diameter, okay, or when the inscribed angle make a semicircle, alright, because now, look, the chord across from the center. So it means it goes through the center. Since it goes through the center, it makes a diameter, okay? So it is always, the measure of that special case is always 90 degrees. Why? Because the measure of a semicircle is 180. What is half of it? It's going to be 90. That's why always, if the inscribed angles include a diameter, so it is going to be a right angle. Or, in another word, we can say that if our inscribed angle include a semicircle, alright, so it is going to be a right angle. Here we have got an interesting example, which is it asks us find the value of x and y. As you can see, guys, here the arc, which is the chord, the chord made diameter, or the arc is exactly a semicircle. So the angle is going to be half of it. What is the measure of a semicircle? Arc 180. So what is, we said that the inscribed angle is half of the arc against it, okay? So here it's going to be 90 degrees. Alright, what is the measure of that angle? 90 degrees. So 2x equal to 90. Now the smart students will ask themselves, 2 multiplied by what is equal to 90? Well, 2 multiplied by 45. Or I told my students in this way that we can divide it by 2 both sides in order to kill this 2. Then x is going to be 90 divided by 2, 45 degrees. But it asks something more, which is the measure of y. So y is exactly the semicircle, the measure of the semicircle, which is 180 degrees. So y is equal to 180 degrees. And that's all about this special case. Well, the last part of this section is about inscribed quadrilateral. Guys, we defined quadrilateral in chapter 5. When we face to polygon, we said quadrilaterals are those kind of polygons that they have 4 angles and 4 sides. Alright, so inscribed quadrilateral is a kind of quadrilateral that is inside a circle. Okay, as you can see, our quadrilateral is exactly inside the circle. Okay, so there is a special point regarding inscribed quadrilateral, and it says, in an inscribed quadrilateral, when we have these kind of figures, alright, opposite angles make supplementary angles. Okay, Mr. Ahmad, what are supplementary angles? Supplementary angles are 2 angles that if you take the sum of them, the sum of the measures of them, they will be equal to 180 degrees. Remember, we had complementary angles and supplementary angles. So the complementary angles The sum of them was equal to 90 degrees. But it says, whenever we have inscribed and quadrilaterals, opposite angles, when you add their measures, the result is going to be 180. That's why we can claim that the opposite angles, they will make supplementary angles. As an example, let's say angle A and angle C, they are opposite angles, okay? So whenever you add the measures, the result is going to be 180 degrees since they are supplementary angles. Here is going to be the last example regarding this section, and it is about inscribed quadrilateral. Guys, all the questions regarding this section they have the same idea from each part. That's why I wrote, like maybe you think that I wrote less question, but you can go and practice, and if you had any question, you can just ask me anywhere that you could. But here we have an inscribed quadrilateral. So find the value of x. First of all, we said in inscribed quadrilateral, opposite angles will make supplementary angles. Okay? So it means if we add them, let's add them 6x, or let's start with this point. Angle A plus angle C is equal to 180 degrees. What is the measure of angle A? It is equal to 4x minus 30 plus, look, we have sum. So plus, what is the measure of C? 6x plus 10. 6x plus 10. And it is equal to 180. Great. So like terms, we can add them. And here we have 4x and 6x. So 4x and 6x, they will make 10x. Negative 30 and positive 10, they will be negative 20. Alright, because they are different in terms of signs, so we will subtract them and keep the sign of the bigger term, which is here negative, equal to 180. Then here we have got a simple equation, move the number to one side, so negative 20 will come to here, and it will become positive because we change the sign of a term. So it will become positive 20. 10x is equal to 180 plus 20 is equal to 200. Now 10 multiplied by what is equal to 200? X equal to 20. Or you can just simply ask yourself, divide both sides by 10 to isolate x, and x equal to 200 divided by 10, 1 0 cancel 1 0, 20 divided by 1, 20. And that was about section 6.4. I hope that you understood it. Thank you so much for listening.